Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. This is a video presentation for PSM1, which is Project Sarjana Muda 1. My name is Mohd Faris Aiman bin Nizam. My project title is Portable Power Monitoring with Notification Capability for Residential Electrical System, and my supervisor is Encik Omar bin Abu Hassan. I will start with the introduction. First is the background of project. Electricity is a vital necessity for human survival. Society increasingly relies on the electrical energy to perform various daily tasks in this highly developed world. Therefore, monitoring the correct use of electrical energy source is critically important for all people to prevent energy wastage. Today, TNB requires individuals to physically visit a home or business, take a meter reading, and then submit the amount to be paid. Consequently, numerous customers filed complaints against TNB because their bills were excessively high. Besides that, a user-friendly smart distribution box equipped with Internet of Things technology is used to monitor daily, weekly, or monthly electricity consumption. In addition, the lack of a monitoring system leads to excessive electricity consumption in homes and businesses. Thus, developing portable power monitoring with notification capability for residential electrical system will help consumers reduce their electricity consumption and identify the home with the highest load consumption. Next is the problem statement of the project. The typical domestic protection system is manually controlled, requiring time and effort to restore the power supply if a short circuit occurs when no one is home. Such a scenario is undesirable because it can lead to an effect on electrical appliances such as the refrigerator, CCTV, security system, and the fire alarm. In addition, consumers are frequently careless with their electrical usage, such as using the air conditioner for too long, which causes the electric bill to rise. Thus, a good system is one that can monitor and measure the current, voltage, and kilowatt consumption in each MCB in order to alert the user of any excessive MCB consumption through online. The measured data will be stored in a single database for analysis. Next is the objective. The objective of this project are, first, to investigate the residential power monitoring system that have voltage, current, and power consumption monitoring capability. Second, to design and construct the portable housing monitoring system using IoT and notification. And the last is to validate the design system to ensure its functionality of the system. Next is the scope and limitation. First, the project used ESP8266 control module as an interface of the hardware. A standard micro USB cable can be used for connecting the microcontroller to the power supply. Second, split core current transformer SCT013 used to measure and sense current usage of the residential electrical system. Third, the voltage sensor ZMPT101B used to measure the voltage of the residential electrical system. 4. The platform of IoT is based on the Blink application used to monitor the data acquired by the split core current transformer and voltage sensor through the internet by using a smartphone. 5. The construct system will be implemented on the distribution box in the house for power monitoring. And the last, the system can monitor the current for each MCB which is load and can display current voltage and power which can be interchanged using the button menu. The next part is the methodology. This is the project flowchart for PSM1. Start with the project title, selection and discussion. And next, research and information gathering. If understand about the title, and research. Continue with sketch and designation of the project. And next, familiarization and selection of suitable component. Next, continue to the design a small circuit and testing the circuit. If the circuit not working, troubleshoot the circuit and test the circuit again. If yes, implementation of the MCU with Blink application. And next, fulfill the report of PSM1. And the last is PSM1 presentation. This is the flowchart of monitoring system of this project. First, system initialization of ESP8266 connect to the Wi-Fi, and then current transformer and voltage sensor read the data value. Any supply is on. If no, current transformer and voltage sensor read the data value again. If yes, current and voltage signal sends to the ESP8266. And then ESP8266 receive the signal and process the data, and the data will display to on LCD display on the control box. And next, ESP8266 upload the data to the Blink application, and Blink application visualize the data by using the smartphone. This is the block diagram of this project. There are 4 sections, which is input, output, microcontroller, and IoT platform. The sensor, which is AC voltage sensor and current transformer, will be connected to the node MCU ESP8266. The AC voltage sensor will be tagged in ELCB in distribution box, and the current transformer will be clamped to the live conductor of MCB, depends on user demand. And then the data will display in the LCD display and can be interchanged using the button menu. And then the MCU ESP8266 will interfacing with the Blink application, and the data will display in the Blink application, and user can monitor the data, which is current, voltage, and power in the smartphone. This is the expected design of this project. We have distribution box, installed DB. We have control box, the distribution box, the current transformer will clamp to the live conductor of the MCB, of each MCB, and the voltage sensor will be tagged in the ELCB, and then the sensor will connected to the ESP8266, and the data will display to the LCD screen. And interchange button we use to each MCB that the user want to monitor. For example, the first button is for MCB1. If the user push the push button 1, the data of the MCB1, which is current, voltage, and power, will display on the LCD. And the MCU ESP8266 will interfacing with the Blink application and can monitor via smartphone. This is the preliminary result. This is the current transformer SCT013 testing. As you can see here, the current transformer is clamped to the socket outlet wire conductor and connected to the node MCU ESP8266, and the current will display in the serial monitor in the Arduino IDE, and the digital multimeter used to calibrate to compare the value of current transformer in serial monitor and the value of the digital multimeter. This is the experimental setup and testing with Blink application. As you can see, this is the smartphone. This is the current monitoring via IoT using Blink application. By using a smartphone, the current transformer SCT013 will clamp to the wire connector of circuit outlet and connect to the ESP8266. This is the graph current versus time for low load that has been exported from Blink application and plot in MATLAB software. The load that produced below 1 ampere assumed as a low load such as phone charger. The starting of current reading is 0.05. That means the socket is turned off. The current reading is around 0.05 ampere because of the noise of the current filter board. Because of the noise of the current transformer filter board. After the phone charger is plugged in the socket outlet and the socket outlet is turned on, the current reading is increased around 0.19 to 0.23 ampere. This is the graph current versus time for medium load that has been generated in MATLAB software from the Blink application. The load that produces more than 5 ampere assumed as a medium load, such as hairdryer. The current reading starting from 0.02 ampere, that means no current flow to the socket outlet. After the hairdryer is plugged into the socket outlet and speed and heat mode are in level 1, the current reading increase around 1.0 ampere to 1.84 ampere. In level 1, speed mode and level 2 heat mode, the current reading increased around 3.09 ampere to 3.63 ampere. In level speed and heat of hairdryer are in level 2, which is the highest mode, the current reading increased around 6.3 ampere to 6.68 ampere. After the speed and heat mode of hairdryer are decreased, the current reading also decreased to 0.02 ampere. This is the graph current versus time for high load has been produced in MATLAB software from Blink application. The high load is assumed to appliances that have the current up to 10 ampere, such as the electrical kettle. The starting current reading is around 0.02 ampere is considered that no load that has been plugged in to the socket outlet. After the electrical kettle was plugged into the socket outlet, the current flow through the coil or the heating element heat the water inside it to the boiling point. The current reading increased around 13.04 ampere to 14.98 ampere. After the water achieves the boiling point, the current will cut off and the current reading decrease slowly from 13.56 ampere to 0.02 ampere. This is the Gantt chart of PSM1 in week 1 and 2. Idea accumulation and choose title for PSM1 is done. In week 3 and 4, topic selection and update in SMAP, determining and verification of the SYNOPSIS. And objective, write the literature review, training on the designation of the circuit. Next, in week 6, identify in week 6 to week 11, identify the material component required for this project, and then write the methodology in week 7, start write the preliminary result in V8 and write the conclusion in V10, and then submit the report to the supervisor in V11 and 12, and then submit report to the panel in V13 also, and slide and video presentation also submit in V13, and the last is Q&A season in V13 and 14. In the future work, for PSM2, the microcontroller used in PSM1, which is ESP8266, will be changed to the ESP32 in PSM2 because the analog pin of the ESP32 more than the analog pin in the ESP8266. In PSM2, the full setup of the project hardware and software will be continued. After the MCU ESP32 and variable sensor are successful, the recording and collecting of data will be implemented. Lastly, the presentation of the report together with the prototype will be implemented in PSM2. That's all from me. Thank you.